Hey everyone, so today I'm going to be telling you about Hooke's Law, and this is more in the GCSE level, so not so much pre-university level. So, Hooke's Law. So, this comes from this guy, Hooke, that discovered that the extension of a stretched wire or spring is proportional to the load that you apply on it, or the force if you want to think about it. So, he saw this formula that you have in there, which says F force equals K, which stands for the stiffness constant or the spring constant, times E, the extension of the wire or the spring. So force comes in newtons. The stiff constant is going to be in newtons over meters, or newtons over meters, or if you want, you can put newtons over centimeters. And then the number depends on the material that is being stretched. So different springs, different wires will have a different stiffness constant. And finally, times, as I told you, the extension of the wire or spring, and the extension will be meters. But however, sometimes it's easier, depending on what you're extending, to put it in centimeters or millimeters, which would mean that the stiffness constant would be newtons over, and then either centimeters or millimeters if you decide not to use meters, okay? So, the Hooke's law, as I told you, works equally well on springs. So, this is for anything that is being extended, really, or stretched, really. And a spring can be compressed, so you can use compressive forces, or it was supposed to say or in here, stretch, which you would have tensile forces. So Hooke's law will work as well if you're compressing something. So again, compress is because of compressive forces, and stretch due to tensile forces, so forces that are trying to pull the spring apart. The compression or the extension of the spring will be proportional to the force applied, and again, in such a way that is F equals K times E, just a formula that we learned about just a minute ago, and the spring constant or the spring stiffness is going to be the K, okay? Now, Hooke's law has a limit. If you think about it, just pick any object, a spring, a wire, an elastic, a rubber band, any of these things. If you get the force or the load, if you want to call it load, to be big enough, Hooke's law stops being obeyed or stops working, as I wrote in there. Now, if you think about it again, if you're trying this at home, you may see that you break either the spring or the elastic band or any of these things. So there is a limit for it, okay? So when Hooke's law is being obeyed, the graph of force versus extension is a straight line. So if I put here my numbers for the extension that I get, for the force that I apply, I get a nice straight line. If Hooke's law stops being obeyed, I will know automatically when I do my graph, because the graph stops being a straight line and starts to curve. Now, sometimes you may see a curve going in downwards, other times a curve going upwards. So it depends really on the material. But the force and the extension are not going to be directly proportional anymore. Or the gradient of the graph, which would be if you would do force over extension, would not be the same number all the time. And that number would be the stiffness constant, okay? So when that happens, Hooke's law is not being obeyed anymore. Now, the point where Hooke's law stops being obeyed, it has a specific name. It's called the elastic limit. So the point where the line in a graph starts to curve is known as E, elastic limit. Or if I'm doing an experiment, for example, and I've noticed that my spring is not returning to the original position anymore, I can say my spring is reaching or has reached the elastic limit if, it's not going back anymore to the original place. So again, I can use it in graphs, as you can see it in here, the elastic limit, or I can just talk about it without even having to use a graph, okay? So that means that whenever I have deformations, I can have plastic or elastic deformations, okay? So deformation or stretch, they can be elastic, which would mean is a temporary stretch, or plastic, which means is a permanent one. So if you have a temporary deformation or an elastic one, the material will return to the original shape after the load is removed, after you take away the force that was being applied. And in metals, for example, elastic deformation happens as long as Hooke's law is being obeyed. And then if you have a plastic deformation, which is a permanent one, the material won't return to the original position once the load is removed, or even if the load is removed. And again, a metal that is stretched past the elastic limit will deform plastically. No matter what you do, it will not return to the original shape, okay? And here it is again. So they call it here strain. Don't worry about it. This is just the tension that you're applying on the spring in this case. Here is going to be the stress that they are applying to it. Don't worry about it too much. What I really want you to see this picture for, that I just got on the internet, is this part X. So the extension, because I have been telling you about extension, but I didn't really show you in a picture how you measure extension. So extension is the difference in between the final length of your spring or wire minus the initial length or of your wire or spring. So this is the spring without any loads or with a load of 0 newtons, and this is exactly the same distance in here. However, when you put a force, then the spring extends. So the extension is going to be the difference in between the final length of my spring and the initial one, L. Okay, so that is it for today about Hooke's law and about plastic and elastic deformations. Remember the formula. There we go, the formula. And remember that Hooke's law may or may not be obeyed, and the moment that it's not obeyed anymore, I get a plastic deformation because I went past the elastic limit. I hope it made sense, and up to my next video, be happy and healthy. Bye!